Hello and welcome back. Everything in geology starts with core. So, what is a core? Core is a cylindrical rock sample recovered from the well while it was being drilled. In other words, it is our original rock, the first and most credible source of information on geological structure, rock properties, sedimentary environment, and in the long run, presence of oil. Cores are recovered with a special drilling equipment called coring head or coring tool. At regular interval varying from half a meter to 6 meters and more. A core is broken away from the bottom hole and lifted up to the surface along with the coring tool. The depth at which the core was drilled out is recorded. First, the cores are analyzed visually. This is called macro description. Then, they are cut in two along the length of a cylinder. Each of the half cylinders is used for chemical, geological, petrographic analysis and for determination of rock physical and mechanical properties. The remaining core material is stored in a special storage facilities like books are stored in libraries. The efficiency of core recovery is described as percentage of the total distance drilled. If the core recovery is 100%, it means that we can confidently study the whole mass of rock penetrated by the well bore and determine petroleum reserves. In geology, cores are everything. Today I want to show you several core samples very typical for different sedimentary environments. Look at the one I'm holding now. It was recovered from the famous Bajenov suite. See the imprint left by bivalve mollusk. This mollusk is called bucha and it can survive in a low oxygen environment. There are no remains of animals that could be found on seafloor. So, this was probably a deep marine environment. In another sample, you can see the sites of bituminous deposits. You cannot feel this very distinctive smell, but you can see the black color. So, these rocks were formed in deep marine environment, and it is not reservoir rock. The next one is finely laminated. It was formed in a so-called microtidal lagoon or barrier island. Microtidal means that the tide level was less than 2 meters. Such islands were rich in long beaches with very few or non-steady tidal channels. This is non-reservoir rock either, although it is partially permeable and might serve as a buffer to fluid flow. This is a coarse grain samples with cobble inside. Such rocks are typical for braided rivers. These rivers are heavily loaded with sedimentary materials. Every now and then the sediments build massive sandbars in the center of the river. These bars look like islands that split the river channel in two. These repeats over and over again, making a whole network of channels. Sediments deposited in such environment contain sand, cobblestones, almost no fine-grained silts and shales, and build laterally continuous cyclic series. They are typically conglomerates and coarse-grained sandstone with low content of fine-grained material and very rare organic fossils. This might be reservoir rock with medium properties. Now look at this little plaque. Where did it come from? It was drilled out of core samples and given to the laboratory for analysis. This comes from a meandering river floodplain. During a high water period, the river flooded a certain area, bringing a fine-grained suspension of sand, silts, and shells which later settled down and formed this thin laminated rock. This is not reservoir rock. This is coal. It might originate from a river delta as channels were slowly dying and overgrowing with vegetation. It is not reservoir rock, but coal is a great marker, very distinctive on several results and can be correlated from one well to another. Our last sample is massive coarse-grained sandstone, most probably from the top of Sandbar. It is a great reservoir rock. Now you know more about cores. See you!